Good day, my wonderful viewers. In this session, we'll be using linear regression to predict the relationship that exists between blood pressure and age and exercise status. Age and exercise status will be our feature variable, which we're going to use to predict our target, which is the word blood pressure. We need to import certain important libraries. We'll be importing pandas to read the data frame. We'll be importing joblib so that we could use this to save our model. We have matplotlib and seaborn that we'll use for visualization. Then we also have to import all these for us to create the model and also to evaluate how the model is working. The first is to import our data frame and store it in a variable called blood pressure. Here we'll try to use a function, head function, to see the first 10 rows of our data. Down here, we'll try to use the describe function to consider certain statistics behind our data. Here, we could see different statistics behind our data. Here, we'll try to use the isNull function to check whether our data has any null function. Here, we'll try to use the .info function to try to see that the data within each column is in the right format. Okay, let's continue. If we check here, we'll realize that age is numerical, but our exercise status is non-numerical. Here, it is categorical. And because we are working on linear regression, we've got to convert this to a binary number. Active will be 1 because it shows that the person does exercises. Sedentary will be 0. It shows the person does not do exercises. And down here, such conversion has been done. We have to use the lambda function. Simply explain here, lambda x, 1 if x is equal to active. That is, if the person does exercise, assign the value 1 to the person. But if the person does not do exercise, assign the value 0 to the person. Then after this, we also have to just use the .head function to recall our blood pressure variable to see whether the effect has been taking place. If we check here now, it has been done. The next thing now is for us to define our x and our y variable. The x variable includes the age and the exercise status, while the y variable includes the systolic pressure and the diastolic pressure. Of course, the systolic pressure in a layman's language, when you visit any of these clinics, is the figure that comes as the numerator, while the diastolic pressure is the one that comes as the denominator. The data is now split into the x train, x test, y train, y test. Now, before proceeding, we decide to check whether there is a relationship between age and systolic pressure and age and diastolic pressure. And we have to use this. Of course, here we are using both matplotlib and seaborn to do the visualization. And we could see that there is a progressive relationship between age and systolic pressure. If we go down, we also realize there is also a relationship between age and diastolic pressure. Since all the data we have in our data frame aren't all numerical, so we decided to just take the numerical value and check the relationship that exists between them using correlation matrix diagram. And this is the result of the correlation matrix diagram. The next thing is to create a linear regression model and fit in our x train and our y train into this linear regression model. And of course, this code is used to do that. We save this in our blood pressure _model. The next step, of course, is to now do simple prediction, and we store such variable in our s_y_thread. Next is to evaluate our model using our R2 score and mean squared error. And after doing that, this happened to be the value we got. Well, our model is not doing too bad, at least it is above an average. Knowing that there are other factors that could bring about the progression or that can affect our blood pressure. But here, the focus is just on age and exercise status. Next, we decided to visualize our predicted value and our actual value. And after that, we realized that there is a correlation between our actual value, which we have from the table, and our predicted value. Otherwise, this model would serve more than up to 55%. After that, the next thing is for us to save our model. Remember, we've already imported the joblib library when we started, and our model is now saved in joblib.dump. Of course, we know the processes involved, and the model is saved. And with this model now, we can recall the model and do simple prediction. Now let's use this model to run certain prediction. Now let's utilize our model. In the first instance, we want to predict the blood pressure of someone that is 65 years old. Remember, 0 means no exercise, that does not do exercise. Using our model, the person is expected to have 148 systolic pressure, 94 diastolic pressure. Now let's check. Let's assume the person does exercise, so we have to change the 0 to what? 1. If that is done, let's see what happens. You can see the person's blood pressure has reduced. Systolic pressure of 133 and diastolic pressure of what? 84. Let's check for another age. Let's assume the person is 55 years and the person does not do exercise. Let's see what the pressure will be. The person has 143 systolic, 92 diastolic. Now let's check if the person does exercises and the person is still the same age, 55, and exercise code 1. You could see the person's pressure is to 128. So what does this thing mean? It means do exercise. Oh, thank you.